So we got to play around with US and Chinese smokers. Oops, what happened? So let's clip this out. Take a look at the important parts. So we've got data from the World Health Organization 2006. They report 3.7 of adult women in China smoke tobacco products, and 19% in the United States.
Big difference.
Okay, so there's a big difference between US and China. And we're just asked a couple of questions about this to interpret this data. Out of 100 women in China, about how many are smokers then? What's that? Yeah, it'd be 100 times that. So they give us, so there's a couple ways to think about it. You could just take 3.7 and times it by 100, in which case you'll get 3.7. Now, can we have 3.7 women? No, so we'd probably say about 4 women. So on the calculator, right, you'd have to turn that into a decimal. Now, let me just make a note here. Percent means what? Out of 100. So really this right here says 3.7 out of 100. And the question asks how many out of 100? So right away I can just say, hey, well, it's the numerator because it's already out of 100. No, the question was how many women out of 100? And doesn't this fraction tell me how many out of 100? Yeah, so right away I can just say, hey, it's 3.7. Now I can't have 0.7 of a women, so I'd have to say about 4 out of 100 women. In China smoke. Is it all right? What's 3.7% of 100?
So
You multiply.
3.7.
3.7%. How do you write 3.7% as a regular number? No, that would be 37%. So 0.37 would be 37 out of 100, which is 37%. It would be 0.037. So for the next part, we want to know how many out of 1,000. So what can we do there? We have 2 options at least. You could just multiply it by 1,000, yep. So you could take the 3.7% times 1,000. So one option would be to take 3.7 as a decimal, 3.7% as a decimal, which would be 0.037, right? Because there's the hundredths spot. That's where the 3 has to go. Multiply it by 1,000. Another option is to think about it as a ratio. 3.7% means 3.7 out of 100. I want to know how many is that out of 1,000. And there's a couple of ways to attack that. One way is to realize to get from 100 to 1,000, what could you do? Yeah, you multiply by 10. So you should do the same thing to the top to get a fraction that's equal. Multiplying by 10 is just going to shift that decimal over. So that means it should be 37 out of 1,000. So I'm going to show one more way to think about it, just to get used to decimals and percents, because that's going to be kind of the theme of the rest of the course. 3.7%. Percent means divide by 100. Divide by 100 means shift the decimal place twice. So that's going to give me 0.037. when I read that, I just read it as slang. What's the proper way to figure out how to say 0.037 instead of slang? I would have to identify place value, right? What's the furthest place value to the left there, or to the right? That's the thousand. So the proper way to read this is it is 37 thousandths is the proper way to read it. Which doesn't that answer the question we're working on? What out of 1,000? So we get 37 for that one. 37 out of 1,000 women in China smoke is what I wrote down here. Yeah. All right. All right, so I'm going to leave it to you guys to finish the other ones. They're not too bad. I'm going to jump over to the next page. So as we saw the other day when I was breaking out the spreadsheet for women and men and smoking and non-smoking in each of those colleges, the Midland College and the Northwest College, there's different ways to look at the percentages, whether you look at it by gender or whether you look at it by smokers. Now here, a teacher collected data about the grades of students, A, B, C, D, E, and F. And they have two different classes. There's two ways they can organize those percentages. They can organize the percent by class, or they can organize the percent by grade. Now notice, there's different percentages in each table, but these are the same exact students. Yeah.
So like, it asks if there are more women in China or the US, wouldn't you have to know the population of both?
Correct, you would, yeah.
So,
Yes. Yeah, and that was on one of the earlier worksheets too. We talked about Chinese and US populations back when we did the water footprint. So you can either look it up online or just look it up on that water footprint activity. Good question. So the first one here, let's see, they tell us which is which. Yeah, the first one is organized by grade. Is that right? Yeah. Because if you look across and you add up those percentages, you get 100% by class, sorry. 100% for the morning class, 100% for the afternoon class. So what this 12.5 tells me is 12.5% of the morning class got A's. Okay. I'm just going to steal that new table and write that down. New page, screenshots.
Hey, Professor.
Yeah.
Can you see what you're doing on
It
the?
disappeared? Oh, crap.
Yes, because I see the room.
Okay, do you see it now?
Oh, perfect.
Okay, sorry about that. Did that just happen?
Yeah.
Okay. All right, hopefully it stays this time. So again, if you scan across row 1, those are going to add up to 100%. Whereas if you look down in this table here, if you go down through the A column, it adds up to 100% that way. So interpretation of each of these is going to look something like this. If I pick on the 12.5%, that tells me that 12.5% of the morning class got A's. If we come down here in the second table and we try to do that 44.4%, anybody want to give a shot how to interpret the 44%? Yeah, so this is the same class, but there's two different ways we're looking at the percent. Whether we look at it by grade or by class. So 44.4% of what did what? Do you think? Notice the orientation of how it adds up to 100%.
44% of the students are in the morning class compared to that.
Almost, that got A's. Yeah, so we got to incorporate A's into that. So what this tells me here is that 44.4% of the A's are in the morning class. Because this second table is organized by grade. Top table is organized by class. Just like in the first set of tables, you can look at it in two different directions depending on what your focus group is. So with that in mind, which table would be used to answer what percent of the students who got A's are in the morning class? Is that table 1 or table 2? That's table 2. Why?
But you just said why.
No, you tell me. I know. I just said it.
You just said it. It was because it shows that the percentage of got A's in the morning class compared to the people who got A's in the afternoon.
Yeah. So in general, it's because it's sorted by grades. Okay. So it's table 2 because table 2 is sorted by grades for percents. What about part B there?
Table 1.
Table 1 because?
It shows the actual percentage of the whole class.
Yeah, so that one's sorted by class is the big deal there. Yeah, so the percents are by class in that case. Yeah. It's sorted by grade, right? So if you look at it, there's the A column has 100%, the B column is 100%, the C column is 100%. So that one's sorted by grades. Table A is sorted by class. All right, let's take a look at another problem. There was a question on the homework for 2-3, and I believe it was problem number 2. Does that look like the one, Jenna?
Yes.
Okay. So there's a couple different ways to do this. We need to calculate some percentages. So there were 3,700 students who majored in the humanities fields. What percentage is that of total students? So to figure that out, I got to add up all these numbers to get the total students. Yeah, otherwise I can't calculate the percent because I need a total, and they don't give me the total. So that means I have to whip out my calculator and add up all those numbers right there.
Even though it says 25.
Oh, they give it to me. Ah, right. Okay. So it's already added up for you. Yeah, so it's just what is 3,700 out of 25,000 as a percent. What is? Okay, so let me just try a couple, see what I get. So if I take 3,700 divided by 25 and 2-3, that gives me 14.8. Converting that, sorry, 0.148. Converting that to a percent, it would be 14.8. And so that's what I would enter into the box. Oops, right here. Here? Yeah. So that would be 14.8. And the percent symbol's already there, I don't have to type it. And then I just keep doing that calculation for each one. Now, a quick way to do this is to, since it's in a web page, you can just highlight all those things and copy them, and then bring them into a spreadsheet and paste them. And then once they're in there, I can just delete those percent symbols. I know the total is 25,000 because I remember to read the fine print next to you. And so I can just go equals, click on that number, divide by 25, 1, 2, 3. Oops, I got a decimal point in there. And then hit enter. I can say, hey, make that a percent, please. And then I can fill that down. And so that'll give me them all pretty quick. Otherwise, it's just one at a time on a calculator. So that's kind of a nice trick. If the table is in like a Word doc or a web page, you can generally copy and paste it into a spreadsheet and then do all you want with it. So if you like spreadsheets, that's a quick way to do it. And then based on that, you're just going to, oops, where'd it go? You're going to try and answer some other questions. So what was the most popular major? It's, you know, we can look at the numbers and pretty much tell, looking at that, we don't really need the percents. But then here, we've got some other questions to answer. So that's the hard part there, using a spreadsheet. And I think I put a video here about that. Let's take a look at number 4. Yeah, so that's just like the one we answered.
Okay.
Yeah, so now that we've done that problem, we can look. So help me out. Which table 1 here, is that organized by grade or by class? Yeah, this one's by class, because if you try to add the A column, it doesn't add up to 100%. So that means it's not organized by grade. And if you add across this way, you find that it is 100%. And this one down here is organized by grade, because if you go down each grade column, you see you get 100%. That'll help there. All right, other questions? Okay, so I've got a couple questions for you. If you remember what yep. Okay. So we're going to play around with proportions some more, and that'll work a little into a percentage. So I'm going to do a little lookup here. Area of United States.
If it asks us to explain, we should
If it says explain, I like a sentence too. So you got to come up with a sentence to go with it. All right. So we're going to take a look at, start looking at population density for the next couple of activities. Let's see. New page. Where is my new page button? That's bizarre. Here. There it is. So where population density takes a look at how crowded a certain area is. So for example, to figure that out, you need to know the number of people, and you need to know the amount of area that they have to be in. So let's take a look at this for the United States in general. So I just looked up online, what's the area of the United States? And I get 3.797 million square miles. Copy that. So the area, 3.797 million. So that would be 10 to the 6th, right? Billion would be 10 to the 9th, trillion 10 to the 12th, and this is square miles. Square miles. Anybody remember roughly how many people are in the U.S.? It's like 300-400 million, yeah, somewhere in there. Let's see where we're at today. So let's go U.S. population. And we've got, oh, yeah, no, you were closer to it than me. It's 323.1 million people. So 323.1 million. 320, was it 1.1? What's that?
That was 3.
323.1. Memory today, 323.1. Fix that. 3.1 million is 10 to the 6th, so that's people. So usually population density is measured in people per million. So we need to clean this up a little bit. Top and bottom both have a multiple of 10 to the 6th, so the millions divide out. So then to clean this up, I just have to take the 323.1 people and divide by the 3.797 square miles, and I'll get a number out of that. So whip out your calculators.
So we're doing like people by area.
People by area, yeah, so that's population density. So 323.1 divided by 3.797, and I get about 85, let's call it 85.1, the nearest tenth. People divided by area, yeah, that's population density. So that comes out to about, I forgot, 85.1. Anyone else get that? Can you help me out here? Yeah. 85.1 people per square mile. Try and get a feel for what that's like. You can imagine an acre of land. Acres to square miles. 1 square mile is 640 acres. So if I wanted to convert this, shrink it a little bit. Shrink. There we go. If I take this and multiply it by 1 square mile, is 640 acres. I think I spelled that wrong. Acres. That'll cancel out the square miles and give me people per acre. So calculator again. I want to take that number. Since the 640 is in the bottom, I divide by 640. Oops, it stopped working. All right, let's try up here maybe. Divide by 640. And I get about 0.13, let's do 3 decimal places, 0.133. That would be people per acre. Now that looks a little bit weird because you can't have 0.13 of a person, right? So we could scale that a little bit. If I move the decimal point once, that would be about 1.33. I would have to put a 10 in the bottom because basically I'm multiplying 10 in top and bottom to shift it like that. Oops, cannot spell today. People per acre. So 1 person roughly for every 10 acres. I live on a 50 by 100 lot. That's definitely not an acre. Okay. So what does that mean? Well, we have a lot of wilderness areas, deserts, things like that. So if people get to spread out, every person would have about 10 acres of their own to work with. Okay. So can anyone picture what an acre looks like? 640 acres in a square mile, so that's a fair amount of room. So there's a fair amount of elbow room there. Okay. Let's think about this room for a minute. How many people do we have in this room right now? Well, we got 1, 2, 3, 4, 5, 6, 7 people in this room right now. New page. So let's look at the population density of this room just to get a feel for these numbers.
How many acres did you say one person would get?
10 acres per person, roughly, is what we just calculated. Oops, this is E101, not E100 right now. And we've got, what, 7 of us?
So it's number one.
What's that?
It's number one.
This number 1.
Yeah, this is.
Yeah, we're getting there. All right, let's see. We measured the room a while back. See if I have that in the notes here. We measured it in square feet and square meters. You think it was what? 28 by 25? That sounds about right. Let's just go with that. So Jenna seems to remember it is about 28 by 25. When I multiply those two, I'm going to get square feet. So cleaning that up a little, how much is that? 28 times 25, about 700 square feet. So we've got 7 people per 700 square feet. And we can clean that up a little bit. That means we have the 7 top and bottom divides. So 1 person for every 100 feet squared or square feet. So I want to convert that to either acres or square miles to compare to the other number. So what I could just look up is how many square feet are in an acre. Acre square foot. Google is always there for me. It's amazing. There are 4,560 square feet in 1 acre. Sorry, 43,560. 43,560. So if I want to do a conversion, switch color, of that 1 person per 1,000, sorry, per 100 feet squared, I want to get rid of feet squared and turn it to acres. For 1 acre, there's 43,560. So cleaning that up a little bit, multiplying by 1 is pretty easy. Then I'm going to have to take the 100 into the 43,000. So if you guys could check on your calculator, I believe this is going to come out with 435.6 people per acre. Anyone else get that on the calculator? So multiplying by 1, not much happens. So essentially we have 43,560 divided by 100. Divide by 100 means shift the decimal place twice. So it should be that. So just think about how much room you have in this room right now, your elbow room. You guys don't feel crowded, do you? You do feel crowded? We're invading your space over there? Okay. I don't feel crowded over here. I got plenty of room to walk around. I'm not bumping into anybody. If we all had to live here, would that maybe be a problem? Yeah, it's not what we're used to in this country in terms of elbow room for living space. So it's a little tight, but each of us technically has about 100 square feet of our own. So we each have a little 10 by 10 spot we could claim in this room. Overall, if we scaled that up in an acre to have the same amount of space, there would be over 400 people in that acre. Compare that to the elbow room we have in general in the United States. Now, the cities are totally going to be different. But over here, I had 1 person for every 10 acres. Way more elbow room in the United States compared to this room. Okay, so just kind of getting a feel for what those numbers mean. So we're just going to play around with those divisions and what they mean. So like Emily said, I think we just answered question 1 there on the worksheet. So let me bring it up, see where we're at. But I wanted to give you guys an overview to 3, I want 2, 4. Overview of the idea. Oh, this one says on paper. I got to fix that. Let me do that quick. Online, text or upload. All right, so we're playing around with population density. Population density is a ratio, kind of like miles per gallon. We played with that before. Cubic meters of water per year. So we've been playing with ratios. We're just playing with a different kind here. We're eventually going to turn these ratios into percents in a future lesson. So part 1 was just to take a look at the population density of this room, and we did that in a couple of ways. We have per square foot. We also have per acre. We could do it per mile if we want. Calculate the population density based on a large rectangle that the instructor designates. All right, let's call that large rectangle a 10 by 10 rectangle. Did we already solve that problem? If we have a 10 by 10 rectangle, no. Number 1 says for the room.
Oh.
Right, and the other one says do it for a rectangle. So what if we took these same 7 people and stuck us in a 10 by 10 square? Square is a rectangle. What would the population density be then? We have 7 people. We have a 10 by 10 square foot region. That would give us 7 out of 100 people per square foot. Now, if you flip population density, by the way, that gives you how much room each person has. So just a side note, that's sometimes a useful number. So flip population density, then that would give you square feet per person. So in this tiny area here, that means I would have 100 divided by 7 instead of 7 divided by 100, okay, if I flip it. So it just gives me a slightly different way to look at the numbers. Let's see, 7 goes into 100 how many times? It goes in 10 times for sure, and then 4 with a remainder of, what is that? 14.28. So let's call it about 14.3 square feet per person. So let's see. That would be smaller than each having our own 4x4 lot. Because 4 times 4 would be 16 square feet. Okay. I'm trying to get an idea for what this number means. So I can say that the population density of us in a 10 by 10 square, if I simplify that, that would be 0.07 people per square foot. What does that mean? Your mom says, what the hell does that mean? I don't get it. You could say, hey mom, we could flip it. If we flip it, that means each person has 14 square feet to play with. So think of those tiles out there. Go grab 14 of those tiles. That's your living space. Okay. So it's more like a closet than a room. So we're trying to figure out what these numbers mean. How can they be comparable? All right, let's try another one. So for number 2, our answer is 7 out of 100 people per square foot. Okay? All right. So now consider 1 million people, each standing on their own 2 by 2 square foot. Okay, so how many square feet is that altogether? Yeah, each person has 4 square feet, right? That's way less than if all 7 of us squeezed into a 10 by 10 room. Okay, because if we all squeeze into a 10 by 10 room, we each have 14 square feet of our own space. Now you only have 4 square feet of your own space. Okay, so what we want to do next is we want to calculate the population density per square mile. I'm going to give you guys a minute to try and mess with this. What happens if we try to scale up? We have, right now we're saying the density is 1 person per 4 square feet. What's that? Well, careful, it says, so how do I incorporate the million there? So although there's 1 million people, how much area does each person have? Each person has 4 square feet, right? 2 times 2 is 4 square. So the bottom line, the density, even though there's 1 million people, it's still 1 person per 4 square feet. That's the population density, right? If you don't believe me, we can double check by saying take 1 million people. Oops, another 0 there. If each person needs 4 square feet, how many square feet do we need total for all those people? Each person has 4 square feet. There's 1 million people. How many square feet do we need altogether? How many floor tiles do we need altogether? We need 4 million floor tiles, correct? All right. Can we reduce that fraction? What's it reduced to? Yeah, that's the 1 out of 4 I was saying. Yeah, so they told us there were 1 million people. That's kind of almost irrelevant. What matters is bottom line, they gave us the population density of 1 person per 4 square feet. That's a hard one to say 5 times fast. All right, so what we need to do next, so we know that reduces down to 1/4 of a person per square foot. There's another way to look at that. So 0.25 people per square foot. We need to scale this up. What's the population density in people per square mile? So usually population density is measured in people per mile squared. So what you guys need to do right now is attempt to convert the units. So give it a shot, come up with some number, and then I'll show you how I do it, and we'll double check. Try some. Don't worry about being wrong. Don't write it down on your paper if that makes you nervous. Whip out a calculator, whip out a piece of paper. Wow, we need to convert people per square foot to people per mile. What did you want to know? Feet in a mile?
Yeah.
There's 5,280 feet in a mile. Yeah, that is an important fact here. All right, so I'm going to do the calculation off to the side here, and then we'll see what we got. Let's see, I need a calculator. Okay, I got a number. Anybody want to take a guess at what they think the answer is? So we have 0.25 people per foot squared is equal to some number of people per mile squared. What's that? I didn't hear it. Louder.
1,320?
More.
You gotta know how many square feet are in a mile.
You gotta know how many square feet are in a square mile. See, the problem here is this is only feet in a mile. I need it to be square feet in a square mile. How do I change this to that new fact? Not times it by 2. How do you square something? You multiply by itself, yeah. So on both sides, I need to multiply these guys by itself. So essentially what I have to do is to convert this, I gotta square both sides. So that'll give me a new fact. 5,280 times 5,280, that's a big number. 5,280. Let me here, repeat. 10,560 feet squared in 1 mile squared. Yeah, so that's the conversion factor I need. So to get rid of feet squared, I'm going to have to multiply by the 10,560. So new page, or actually go to this page here. So I'm going to take my 0.25 people per foot squared. I need to multiply that by the conversion factor. 10,560, is that right, Jenna? Mm-hmm. Feet squared per 1 mile squared. That allows me to eliminate square feet and give me an answer in square miles. So calculator, if I take that number times, weird, why won't that work for me? Times 0.25. All right, I get 2,640 people per square mile.
Could you do
Oh, no, I did that wrong.
Yeah.
That's supposed to be squared. There we go. I get 6,969,600 people per square mile. Right, so we'd be packed in like sardines. No, you got to square the miles first and then multiply by the 0.25. Otherwise, the order of operations is incorrect. Yeah, so you can't square it after, you got to square it before to get the conversion factor right. Right here? Yeah.
So is it 16 whatever people?
Oh, wait, something's not right here. Maybe this number's not right. Let me double check that. If I take 5,280 times 5,280. Oh, okay, so the 10,000 is not right. 5,280 times 5,280 is 27,878,400. Okay, yeah, so it's not times 2, it's squared. Yeah, it's got to be squared. Yeah, so correction, that is not right. It's a really big number, yeah. So it's 27, almost 28 million square feet in a square mile. Yeah, so that gives us about approximately 6 million something, almost 7 million people. In each square mile. All right, we're out of time for fun with math today. Tristan's itching to go. We better let him get out of here. We'll continue to work on this on Monday. If you're falling behind in your homework and prep, please get it done. You got it for me? Thank you, sir. Thank you very much. If you have worksheet 3 done, I'll gladly take it. If you need more time, then come see me for help. Yeah, I always found population density, it seems straightforward at first glance, but thinking about what it really means is a little tricky. It takes some getting used to.
I really get